Dbms second part, view of data. What is view of data? A da- what is view of data? A database system is a collection of interrelated data and a set of programs that allow users to access and modify this data. A major purpose of database system to provide users with an abstract view of the data. That is, the system hides certain details of how the data are stored and maintained. A view of data means data is stored and maintained in hidden part. That is a view of data. Next, the data abstraction. For the system to be usable, it must retrieve data efficiently. The need for efficiency has led designers to use complex data structures to represent data in database. Since my database system users are not computer trained, developers hide the complexity from users through several levels of abstraction to simplify users' interactions with the system. This is data abstraction. Data abstraction is a for the system to be usable, it must retrieve data efficiently, and the need for efficiency has led designers to use complex data structure to represent data in the database. Complex data structure is used since many database system users are not computer trained. Developers hide the complexity from users through several levels of abstraction to simplify users' interactions with the system. This is data abstraction. This picture, these are users. External schema is external view. Conceptual schema is conceptual view. Internal schema is internal view. And this is a database disk. This is a figure of levels of abstractions in a DBMS. Which are levels of abstraction in DBMS? Physical level, that is a internal view or internal schema. This is a physical level. Physical level, the lowest level of abstraction describes how the data are actually stored. The physical level describes the complex low-level data structures in detail. This is a physical view in abstraction levels. Logical level or conceptual view schema. Logical level means conceptual view or schema. The next higher level of abstraction describes what data stored in the database and what relation may exist among the data. The logical level thus describes the entire database in terms of small number of relatively simple structures. Although implementation of simple structures of the logical level may involve complex physical level structures, the user of the logical level does not need to aware of this complexity. This is referred to as physical data independence. That is a physical logical level or conceptual view. Next, wave level or external view or schema. The highest level of abstraction describes only part of the entire database. Even though the logical level uses simpler structures, complexity remains because of the variety of information stored in large database. Many users of the database system do not need all this information. Instead, they need to access only a part of the database. The view level of abstraction exists to simplify their interactions with the system. The system may provide many views for the same database. For example, you may describe the record as follows. Type uh, type instructor is equal to record. ID is equal to character 5 length of size. Name is equal to character 20 length of size. Department name character 20 and salary in numeric 8,2 and end is there. This code defines a new record type. Which is new record type? Constructor, with 4 fields. New record type instructor, which has 4 fields. Each field has a name and type associated with it. A university organization may have several such record types, including department, department with fields, department name, building, budget, course with fields, course ID, title, department name, credits. A physical level, at the physical level, at the physical level, an instructor, department, or student record can be described as a block of consecutive storage locations. At the logical level, each such record is described by definitions, as in the previous code segment, and the interrelationship of these record types is defined as well. Finally, at the view level, computer users see a set of application programs that hide details of the data types. At the view level, several views of the database are defined, and database users see some or all of these views. This is a view level, logical level, and physical level. Next, instances and schemas. Database change over time as information is inserted and deleted. The collection of information stored in the database at a particular moment is called as instance of the database. What is instance? The collection of information stored in the database at a particular moment. The overall design of the database is called as overall जो भी design रहेगा उसको क्या बोलेंगे? The schema. Schemas are changed infrequently, if at all. The concept of database schemas and instances can be understood by analogy to program written in a programming language. Each variable has a particular value at a given instant. The values of the variables in a program at a point in time corresponds to an instance of the database schema. The database systems have several schemas, partitioned according to the levels of abstraction. The physical schema describes the database design at the physical level, while the logical schema describes the database design at the logical level. A database may also have several schemas at the view level, sometimes called subschemas, which describe different views of the database. Of these, the logical schema is by far the most important in terms of its effect on application programs. Since programmers construct applications by using the logical schema, application programs are said to exhibit physical data independence if they do not depend on the physical schema, and thus need not to be rewritten if the physical schema changes. These are the types of schema: physical, logical schema. Next, what do you mean by data models? Underlying the structure of database is the data model. Data model is a collection of conceptual tools for describing data relations, and data semantics and consistency constraints. The data models can be classified into 4 different categories. Data model is classified into 4 different categories. One is a relation model, and another is entity relationship model. What do you mean by relation model? The relation model uses a collection of tables to represent both the data and relationship among those data. Each table has multiple columns and each column has a unique name. Tables are known as relations, and the relation model is an example of record-based model. Entity relationship model. The entity relationship data model uses a collection of basic objects called entities and relationship among these objects, that is entities. Suppose that each department has offices in several locations. We want to record the locations at which each employee works. The ER diagram for this variant works in, which we call works into. Example, ternary. This is a works into. Employees are there. Lot. This is the ER diagram. Since locations, address, capacity, departments. This is a ER diagram of library management system. About diagram is ER diagram of variant of workers industry, variant of workers industry, which we will call works industry 2. Employees and departments are there. Locations, address and capacity, employees name, plot, departments, department name, budget. And another diagram is diagram of library management system. Books, books available, price, title, book ID, author, published by, publisher, ID, address, name. Books is related to browse by, due date, return date, issue, member, expiry date, address, member date, member type, member ID, name. Next, passenger and train information. This is a ER model for railway booking system. ER model for railway booking system. Passenger, passenger card, passenger ID, address, contact, train information, departure, location, uh, total seat, seat number, arrival time, destination, source is related to one to many relation, age, gender, name, size, ticket, and travel through route, pickup point, route ID, final price, ticket number, ticket price. This is a ER diagram for railway booking system. ER model, banking transaction system. Object-based data model. Object-oriented programming, especially in Java, C++, or C#, has become the dominant software development methodology. This leads to the development of object-oriented data model that can be seen extending the ER model with notations of encapsulations, methods, that is functions, methods, that is functions, and object identity. Semi-structured data model. The semi-structured data model permits the specification of data, where individual data items of the same type may have different sets of attributes. This is in contrast to the data models mentioned earlier, where every data item of a particular type must have the same set of attributes. The extensible markup language, XML, is widely used to represent semi-structured data. Historically, the network data hierarchical data model proceed the relational data model. These models were tied closely to the underlying implementation and complemented the task of modeling data. As a result, they are used till now, except in old database code that is still in service in some places. Database languages. A database system provides a data definition language to specify the database schema and data manipulation language to express database queries and updates. In practice, the data definition and data manipulation languages are not two separate languages. Instead, they simply form parts of single database language, such as widely used SQL language. Data manipulation language, a data above is data definition language to specify the database schema, and database and data manipulation language to express database queries and updates. Data manipulation language, that is DML, is a language that enables users to access or manipulate data as organized by the appropriate data model. The types of access are retrieval of information stored in database, insertion of new information into the database, deletion of information from the database, modification of information stored in the database. There are basically two types. Procedure DML is require user to specify what data are needed and how to get those data. And declarative DML are also referred as non-procedure DML, require user to specify what data are needed without specifying how to get those data. Query is a statement. What is query? Query is a statement requesting the retrieval of information. The portion of DML that involves information retrieval is called query language. Although technically incorrect, it is a common practice to use the terms query language and data manipulation language synonymously. Next, data definition language. What do you mean by data definition language? We specify database by a set of definition expressed by a special language called a data definition language. The DDL is also used to specify additional properties of the data. Next, domain constraints. A domain of possible values must be associated with every attribute. For example, integer types, character types, date or time types. Declaring an attribute to be a particular domain acts as a constraint on the values that it can take. Domain constraints are the most elementary form of integrity constraint. They are tested easily by the system whenever a new data item is entered into the database. This is a domain constraints. Next, referential integrity. These are cases uh, where we wish to ensure that a value that appears in one relation for a given set of attributes also appears in certain set of attributes in another relation. That is a referential integrity. For example, department listed for each course must be one that actually exists. More precisely, the department name and value in a course record must appear in the department name attribute of same record of department relation. Next, assertion. Assertion is any condition that database must always satisfy. Domain constraints are referential integrity constraints are special forms of assertion. However, there are many constraints that we cannot express by using only these special forms. For example, every department must have at least 5 courses offered every semester must be expressed as an assertion. This is an assertion. Next, authorization. We must to differentiate among the users of the types of access they are permitted and various data values in the database. These differentiations are expressed in terms of authorization. The most common being read authorization, which allows reading but not modification of data. Instance authorization, which allows modification but not declaration of data, and delete authorization, which allows deletion of data. We may assign the user all, none, or a combination of these types of authorization. The DDL, just like any other programming language, gets as input some instruction statements and generates some output. The output of DDL is placed in the data dictionary. We have to place output of DDL in the data dictionary, and which contains metadata. Which data? Metadata. That is data about data. Metadata means data about data. Next, dictionary. What do you mean by dictionary? You must define a data dictionary. There's DBS component that stores the definition of data, characteristics, and relation. You may recall that such data about data were labeled metadata. The DBMS data dictionary provides the DBMS with its cell describing characteristics. In effect, the data dictionary resembles an X-ray of company's entire data set and is crucial element in the data administration function. For example, data dictionary typically stores descriptions for all data elements that are defined in all tables of database, especially the data dictionary stores the name, data type, display format, internal storage formats, validation rules. The data dictionary tells where an element is used, from whom it is used, and so on. Types, tables defined in all databases. Tables defines in all databases. For example, data dictionary is likely to store the name of the table creator. Of the data creation access authorizes the number of columns and so on. Index is defined the each database tables. For each index, at Dbms stores at least index name, the attribute used, the location, index characteristics, and the creation date. Defined databases who created each database, the data of creation where the database is located. DBA is and on end users the administration of the database programs that access the database, including screen formats, report formats, application formats, SQL queries, and so on. This is a DBA. Access authorization for all users of all databases. Relationship among data elements, which elements are involved, whether the relationship mandatory or optional, the connectivity, cardinality, and so on. Database administrators and database users. A primary goal of database system is to retrieve information from and store new information in the database. Next part, database users and user interfaces. There are four different types of database users, differentiated by the way they accept to interact with the system. Different types of user interfaces has been assigned to for the different types of users. First users, naive users, are unsophisticated users who interact with the system by invoking one of the application provisions that have been written previously. For example, bank letter who needs to be transfer $50 from account A to account B. It's a program called transfer. Next, application programs are computer professionals who write application programs. Application programs can choose from many tools to develop user interfaces. Rapid application development tools are tools that enable the application program to construct forms and reports without writing a program. Next, sophisticated users interact with the system without writing programs. This is sophisticated users. Instead, they form their requests in database query language. They submit each such query to a query processor, whose function is to break down Dbms statement to instruction that storage manager understands. Analysts who submit queries to explore data database fall in this category. Online analytical processing, OLAP, to simplify analysis and tasks by treating them with some breeze of data in different ways. For instance, an analyst can see total sales by region, for example, north, south, east, west, or by product, or by a combination of region and product, that is total sales of each product in each region. Next important structure is database architecture. The architecture of a database system is generally influenced by underlying computer system on which database system runs. Database systems can be centralized or client server, where one server machine executes work on behalf of multiple client machines. Database system can also be designed to exploit parallel computer architecture, distributed database, span multiple geographically spaced machines. This is an architecture of their database system. This storage, there is a indices data, data dictionary, statistical data, and in storage manager, a buffer manager, file manager, authorization integrity manager, transaction manager are there. In query manager, compiler and linker, DBL queries, DDL queries, and application program object code, DML compiler, and organizer, query evaluation engine, that is a query processor, storage manager. Next upper part is application interfaces, application programs, query tools, administration tools. Last part is new users, agents, web users, application programs, write, and sophisticated users, analyzed, use, and database administrator use. A database system is partitioned into models that deal with each of the responsibilities for the overall system. The functional components of the database system can be broadly divided into storage manager and query processor component, which is storage manager into the storage manager and query processor. The storage manager is an important because Database typically require a large amount of storage space. The query processor is important because it helps the database system simplify and facilitate access to data. Next diagram. User application, network, database system, user application client, network application server, database system, client and servers are there. This is a two-tier architecture and this is a three-tier architecture. In three-tier architecture, in two-tier architecture, database system. In this application server is not there. This is a common difference between two-tier architecture and three-tier architecture. Query processor. The query processor includes the following component: DDL interpreter,